Hey Math Kids, today we're going to talk about the area under the curve, and it says find the area of the region enclosed by y equals 2x, the x-axis, x equals 0, and x equals 4. Okay, so they want us to do it through a geometric argument and through integration and show that we get the same answer. So geometric argument is going to be, we cross at 0, we go up 2 over 1, and we're going from 0 to 4. So 1, 2, 3, 4. And we go up 2 over 1, up 2 over 1, up 2 over 1. That's supposed to be a straight line. So the area enclosed is just a right triangle. Okay, so the area under that curve is just going to be 1/2 base times height. And so the height is 1, 2, 3, 4, 5, 6, 7, 8. The base is 1, 2, 3, 4. And then we cut that in half. All right, so if we do 4 times 1/2, that gives us 2. And if we multiply those together, we get 16. Okay, so that's our geometric argument. Now we're going to set up an integral from 0 to 4. Our function is 2x. So we want to take the antiderivative. So x raised to the 2 divided by that same number. So let's cancel. So we're just going to evaluate x squared from 0 to 4. So if we plug in a 4, we get 4 squared. Then we subtract, plugging in a 0. And so it's going to be 16 minus 0, or 16. So you see we get the same area no matter which way we do it. Okay, so it says find the area that's enclosed by this function, the x-axis, x equals 1, and x equals 2. Okay, so we're going to set an integral from 1 to 2. Our function is x squared plus 1. And we'll do this. Okay, so we find the antiderivative, raise it by 1, divide by the new exponent. We do that. And we just have from 1 to 2. So if I plug in 2, I get 2 raised to the 3 over 3 plus 2. And then I'm going to plug in a 1. So 1 cubed over 3 plus 1. Okay, we just need to simplify this. So that's going to be 8/3 plus 2. And then minus 1/3 plus 1. Okay, you can simplify this however you choose to. I'm going to distribute this negative. So this is a negative, and this is a negative. So I get 8/3 plus 2 minus 1/3 minus 1. I'm going to do 8/3 minus 1. So that's going to give me 7/3. And then 2 minus 1 is 1. Think of the 1 like it's 3 over 3. And that gives me 10/3. Okay. Moving on. Okay, find the area enclosed by one arc of y equals sine x, 2x, sine of 2x, and the x-axis. Okay, so if we graph this, if it's just sine, so this is not sine of 2x, but if it's just sine, we get something that looks like this. Okay? Now what the 2 is going to do is, since it's multiplying, since it's on the inside, it's counterintuitive, and since it's multiplying, when we look at it on the graph, it's actually dividing, and so if we divide that by 2, it's just pi. So the first arc is just here, and so we can set up our integral from 0 to pi halves, and then do sine of 2x dx. Okay, so the antiderivative of sine is negative cosine. Keep the same inside, and then divide by the derivative of the inside. Then we get pi halves to 0. Okay. Now I'm just going to plug these in, so I get negative cosine of 2 times pi halves all over 2 minus negative cosine of 2 times 0 all over 2. Okay, so if we draw cosine, this just goes to 0, right? 2 times 0 is 0. Cosine of 0 is 1, and so this entire thing becomes negative 1/2. Okay, now we're going to figure out this thing. Well, both those two, so we're just finding cosine of pi, which half of the period is pi, and so this is negative 1. So this entire thing is negative 1. Negative 1 times a negative is positive, so the entire thing in here is 1/2. Okay? Okay, now we have 1/2 minus a negative 1/2, so it's the same thing as saying 1/2 plus 1/2, which is just 1. Okay, if you need additional help, come to Math Lab. Until then, calculator.